lab number 5 and number 6. Oops. All right, so can you guys see my screen now?
Yes, sir.
So last meeting, okay, or yung pinaka-last meeting natin, okay, you were able to understand how a diode works, the characteristics of it, and how it functions, okay? So today, I'll show to you on how to make or create a half-wave rectifier. Well, actually not uh, teach you. I will not teach you how to create it. I'll just guide you, okay? Since for sure, as of now, you guys already know how to put the components, how to configure a certain components, how to edit dissemination command. So I don't need to walk you step by step on how to create that certain circuit. Okay, so today I'll just guide you. Okay, so the objectives of this lab number 5 is to understand the operation of a half-wave rectifier, wherein actually you've already done it. You've already did it with your laboratory number 4. Okay, so to construct the fork curve of a half-wave rectifier. So I will leave discussion part or the reading part to you guys. So I'll just uh, have a brief discussion. Okay, just just a thorough, not really a thorough. Maybe ano ba? We'll just pass by. Okay, I will not explain everything with this one. So as you can see right here, we have an AC, which is this one, and then we have here a DC. Okay, so I know that all of you already know what is an AC and then what is a DC. Okay, so most of you already know that our outlet has an AC voltage. Okay, so some applications, I mean some equipments, okay, is using the AC voltage or AC as a source, but some equipments, okay, like our laptop, so it needs to be converted into DC. Okay, so meron tayong converter wherein we use rectifier. Okay, actually the simplest form of rectifier is half wave. Okay, wherein that is the very first step that we do when we want to smooth out, when we want to smoothen out a certain AC voltage. Okay, so we use rectifier to smooth out a certain voltage. So from AC, as you can see right here, we now have uh, still an AC actually, alternating current, but we clip, or this one now is now only accepting a positive voltage. Okay. So as a result, we get this one a pulsating DC signal. Okay. So to smoothen this one out, we apply capacitor to smoothen this one out. So just like this one. But we cannot attain a perfect DC voltage. Well, we can attain that one if we have a very complicated circuit. Okay, so this one is just to show to you that you can smoothen that out at least a little. Okay, so you can apply a capacitor here for you to smoothen this one. I think I've showed it here. No, I wasn't able to put it here, but just put a capacitor here. Anyway, I will show it to you later on using the LT Spice. If you put a capacitor here, instead of having this pulsating, you will get a smoother pulsating DC output. Okay, it's like almost direct current. Okay. Anyway, so here's one example wherein how to make or how to create a half-wave rectifier. So as you can see right here, the polarity is like this. So this is the anode and then this is the cathode. So during the positive half cycle, it will make this diode a forward bias. So if it's a forward bias, meaning this one will become a short circuit, and then it will allow the current to pass through at this point. So as you can see, our current now is now at our load resistor. Okay, so as a result, whatever is the reading or the voltage output in here will be our voltage output. And then during the negative half cycle, so we now have a negative and then positive here. So negative is connected to the positive, or negative is connected to the anode, and then negative is connected to the cathode. So if that's the case, then this diode will become reverse bias. If it's reverse bias, this one will become an open circuit. So if this one is an open circuit, then of course it will not accept a current or a voltage anymore. So as a result, it will not be able to pass through our load resistor. So that is why we don't have a voltage below the ground level, or below the negative half cycle. So this circuit will only accept positive half cycle. Okay, so this one is already DC since uh, it only accept positive voltage. Okay, so just leave this one. Okay, just make this one the cathode and then the other one the anode. Then this one will now will accept negative voltages. Okay, so that's basically it, the idea of a half-wave rectifier. Now, uh, the thing that you need to do is using the LTSPI 17, create a circuit which will only accept positive half cycle, which is already done in here. Okay, so this can serve as your basis, but okay, you don't need to use an inductor. Okay, just simply use an AC sine wave. Okay, so again, do not use an inductor as your primary and then secondary voltage. So just use an AC sine wave or an AC voltage, okay? So you don't need to use an inductor again. All right, so create a circuit which will only accept the positive half cycle and consider the diode as a silicon. All right, and then paste here the screenshot of your circuit. So that's it for the number one. And then number two, instead of having a positive half cycle, so uh, you all know what to do. So just reverse the diode, and then you will now be able to create a half-wave rectifier wherein it will only accept negative half cycle, right? So same question, it's just that you have to change this one into, or you have to make a circuit wherein it will only accept negative half cycle, okay? So that's it for number two. And then number three, so using the LTSPI 17, create a circuit which will only accept positive half cycle and consider that as a silicon, but this time apply a capacitor to smooth out the pulsating DC. Okay, so positive and then apply a capacitor. Okay, so it is now up to you to experiment on what is the value of your capacitor for you to be able to show or uh, give or to output the smooth out or the smooth pulsating DC. And then number four, same idea with number three, but this time negative. Okay, so create a circuit which will only accept negative, and then also apply a capacitor to smooth out the pulsating. All right, and then paste it also here. And then what is your conclusion from the steps that you have finished? So from step one to step four. All right, so just to give you a basis, I have already created here circuit. So just look on the right side. Okay, this one. So this is a half-wave rectifier. Okay, let me just run again. Wherein this is our voltage input. So as you can see, we have 5 volts peak to peak. And then we've used a silicon diode here. So once it passed through the capacitor, or once it charged the capacitor and then passed through our load resistor, we now have here a positive, or yeah, halfway positive rectifier wherein it's already smoothed out by the capacitor. So if we don't have this capacitor, then it will give you a pulsating DC. Yeah, it's like that. Okay, so it's not that smooth. And as you can see, we only have here a voltage of 4.4 because of course we've used a silicon die. This one is not an ideal diode. Okay, so in your case, also in your laboratory number 5, you should also use silicon. Okay, so yeah, this one is a circuit wherein it doesn't have a capacitor. So if we have a capacitor, you will get this kind of output. Okay. So yeah, that's it for laboratory number 5. Any questions so far? Any clarification or questions so far regarding with the things that you need to do? So number 1 and 2, without a capacitor, so positive half cycle and the negative half cycle. 3 and 4, positive and negative, but this time, apply a capacitor to smooth out the positive. So any clarification so far regarding with laboratory number 5? Hello guys, can you hear me?
Yes, sir.
All right. So question before we proceed to the laboratory number 6. All right. So what about the others? Don't you guys have a question or clarification? All right. So I think the others don't have a question also. But anyway, so if ever that you've encountered the problem, so feel free to ask me anytime or feel free to consult. Okay. All right. So let's move on with your laboratory number 6. So if we have a half-wave rectifier, we also have a full-wave rectifier. Okay. So the objectives of this laboratory is to understand the operation of a full-wave rectifier and then to understand the two types of full-wave rectifier. Okay. And then to construct the four curve of different kinds of full-wave rectifier. So some of you may already know, to those who are enrolled in my lecture, we have two types of full wave rectifier. We have the bridge rectifier and then the center tap rectifier. Okay, so basically the same idea with the half wave rectifier. It's just that uh, full wave rectifier, okay, will accept a positive and negative half cycle at the same time. Okay, so very straightforward. If we have positive, it will also output positive. If we have negative, it will also output negative. So as you can see right here, we have a full wave rectifier or full wave signal. Okay, and then we have here a sample circuit. Okay, wherein this one is a bridge rectifier. Okay, so I think I wasn't able to show the center tap rectifier anymore, but you can just search that on the internet on how does a center tap rectifier work. Basically, uh, the same idea with the full wave. I mean bridge rectifier, but it's only using 2 diodes instead of 4 diodes. Okay, but basically, whatever is the input or whatever is the output in bridge rectifier is the same output with the center tap rectifier. Okay, so in this bridge rectifier, so here on the positive half cycle, D1 and D2 will conduct. Okay, this one, D1 and D2. So why? Let's say we have positive here. So positive, so if our voltage will go here, this one will become reverse bias. Okay, so of course, it will now go here since this one will accept the voltage. So positive to positive and the negative to negative is forward bias. And then it will pass through uh, here in our uh, load resistor. So once it it's done charging the capacitor, okay, and then it will go right here and then go back here. And then, of course, it will not be able to uh, uh, go back here anymore because this one is already an open circuit. So as a result, it will go to B2, okay? And then the same with this D3 since this one is also open circuit since our D sub 1 passes here. So our voltage now or our current will go here and then will go back to our ground, okay? So the same idea with the negative half cycle, it's just that we now have a negative. So negative to negative and then positive to positive. So of course, it will pass here and then here, here, and then here, here, and then here, here, and then we'll go back to our voltage source. Okay. So I've already discussed this one in my lecture. So feel free to ask your classmates the notes that I gave to them for you to understand how does a full wave rectifier work. Okay. So basically, if you don't have a smoothing capacitor, you will get this kind of uh, waveform. Okay, but since we put here a capacitor, then our pulsating DC will be smoothened out. So it is now accepting positive and then negative at the same time, but a smoother voltage output. Right. So in here, I'm only asking you guys to create a bridge rectifier only. Okay, I'll not ask you to make as a, I think I've included. I'm sorry. Okay, so I thought I've only put here a bridge rectifier, but I've included a center tap rectifier. Anyway, this one is very simple. Actually, it's quite more simple than a full wave rectifier because instead of using a 4 diodes, you're only going to use 2 diodes. Okay. So procedure number 1. So using the LT-SPI-17, create a bridge rectifier just like this one. Okay, which will accept the positive and negative half cycle. Of course, since it's fully rectifier, it will now accept positive and negative. At this time, without a filtering capacitor. Okay, and then consider the diode as a silicon. So just like this, okay, but without the capacitor. And then paste here your circuit layout and then the simulated graph of your circuit. And then for the number 2, so the same idea, it's just that uh, right now with a filtering capacitor. So this one also accept positive and negative, but now with a filtering capacitor. So I expect an output just like this on your number 2. Okay. And then for the number 3, so this one is basically the same with the number 1. It's just a different circuit layout. So create a center tap rectifier, which of course will accept positive and negative without a filtering capacitor. Okay. And then for the number 4, so this one is also the same with number 2. Okay. This will accept positive and negative, but of course this time with a filtering capacitor. Right? And then number 5 is what is your conclusion from the steps that you have finished. So any clarification so far regarding with this one before we proceed to the uh, sample output on the out specs? Any clarification or concern or problem or question? Hello guys, you guys still there? Yan pa ba kayo? Buhay pa ba kayo? Alright, so no question coming from Mr. Golaitan. Answer. Alright, so sigurado kayo? Hindi naman ako nagagalit eh. Actually, mas gusto ko yung may kausap. Kasi parang, wala eh, minsan syempre iniisip ko, nandyan pa ba sila or Baka inopen lang tapos kumonek. Tapos, okay, yun yan. Laro na tayo, manood na tayo kung ano man yun. So, mas maganda kung nakikita kong nakiki-participate kasi parang feeling ko interested kayo or nakikinig talaga kayo. Diba? Wala talaga ah. Okay, sige. So, okay, kung wala talaga, di natin magagawa. Anyway, so here's the sample circuit of the full wave rectifier. So just look on the left side, right? So as you can see right here, we have dalawa kasi eh. So supposedly, let me just show to you kasi hindi pa nagawa ng paraan kung hindi ko alam kung bakit ganun. Okay, so supposedly, you have yeah, like this. We have an input like this. Input that will show you the positive and then the negative side of the sine wave. But if we have this ground, so as you can see, we have two grounds. The ground for the source and then the ground for the voltage output. So, pagpapakita lang tong ganito, yung full wave of voltage input if we include a ground here. So, yeah, tama to. Tama tong sa input. But when it comes to output, okay, it only give us the positive half cycle, which is also wrong because this full wave rectifier should accept positive and negative half cycle. Okay? So, para mapakita ko sa inyo kung tumatanggap pa talaga siya ng positive or negative, so you have to remove this ground. Okay? The ground on the voltage source. So just run it again and then voila. So as you can see, let me just double click this one. So this one now is accepting positive and then negative at the same time. So this is the positive half cycle, negative half cycle, positive, negative, positive, negative. All right. So what I would like you guys to do is take a screenshot with the ground here, okay, with the ground, and then just show to me that this is the input, okay, voltage input, a full wave input, and then remove this one and then run it again and then just double click the V out, okay, and then screenshot this one and then this one now is the output. So depende sa inyo, you can change the values, okay, like for example I didn't include the voltage of your sine wave, so you can change this one into 5 volts or 15 volts or 20 volts. It's up to you. So in my case, I've just used 10 volts as my reference, but you can change that one. And then in this one also, I didn't use a silicon diode. As you can see, all of them have the same names, ideal B, ideal B, ideal B, ideal B, because what I use is an ideal diode, okay? So, paano ko ginawa yon? I use spice directive. Okay. So, just right click this one, I mean left click rather, and then just put this parameter. But you don't need to do this one, okay? Because what I required you guys to do in your laboratory number 6 is you must use a silicon, okay? So you don't need to do those kind of parameters, okay? So everything here are silicon. So all of your diodes should be 1N, 14148. So that's the silicon diode for the LT spice, right? Or there's another way which I will also allow. So you can have your ground here and then remove the ground here instead. And then, yeah, so, oops, I think it's the other way around. Oops. Ah, it's not working. Wait, let me just check. This is truly working. No, it's not. Let me remove this one. There you go. So you can also do this one. So that's why I've included here a label. Label net V in plus. This is the positive half cycle. the green one, and then the blue one here is the V in negative, which is the negative half cycle. So you can also do this one to show that it accepts positive. I mean, it has an input of positive and negative at the same time. And then the output will be the red one, which is completely positive and negative half cycle. So yeah, so you can just remove the ground here and then measure this one and then measure the other one also. Okay. So just to show to you that it accepts, I mean, it has an input voltage of positive and negative. All right. So this is without the capacitor. So if it's with capacitor, so just put here capacitor, disconnect it, and then say 50 micro. The sample output now will become like this. So as you can see, we have here a V out of smoothened pulsating DC, right? With the use of capacitor. So it's now almost a DC, right? So any questions so far or clarification?
Sir, ano po yung apat na zero dun sa may sign, ano?
Ah, so those 4 zeros, so punta lang kayo sa simulation, edit simulation. So those are the, wala, ito pala, right click the visa file itself. So actually kahit hindi nyo na-include yan, by default 0 na siya. So nilagay ko lang doon 0 for reference lang na 0 yung delay, 0 yung theta, 0 yung phi, and then 0 yung end cycles. So same pa rin, kagaya ng dati, dalawa lang yung ginagalaw natin, which is the amplitude, the peak-to-peak voltage, and then the frequency, which is, of course, ito kasi yung default sa Pilipinas. Sa US, they have 50 Hz of frequency. Here in the Philippines, we use 60 Hz.
Okay,
And
sir.
then one more thing, okay? One more thing sa simulation command. So don't forget to check this one. Okay? So check nyo to sa half-wave rectifier and then dito rin sa full-wave rectifier. Okay? So this is just to show to you that the external DC will start at 0 hanggang sa positive 10 and then 0 hanggang negative 10. Okay? So check this one out. Alright? So, ganun lang naman. Actually, kayang-kaya niyo yan. Just by looking at my example, I already copied that one and then change some of the necessary changes. So, any questions so far or clarification? Question, guys? So, what I've only shown is the bridge rectifier. So, you can look on my notes or the internet on how to create the center tap rectifier. Right? Any other question or clarification? Hello, guys. You guys still there?
Wala nang question, sir.
Alright, so pwede kayo mag-experiment. Baka malay nyo, magawan nyo ng super smooth na DC. So pwede nyo palitan tong capacitor. 50 to 500 maybe. Kaya natin. Yeah, like that one. See? I've only applied 500 microfarad. So super smooth na ng voltage output natin. It's like completely direct. Alright, so kung wala nang question, so pwede na kayo mag-leave. And then, Ano pa ba? And then see you next meeting. So let's see kung matatapos nyo itong lab 5 and lab number 6. So I think matatapos nyo naman ito. Sobrang dali lang. Alright, so ito na lang muna. So kung wala nang questions, so pwede na ka mag-leave guys. And then happy lunch to all of you.
Bye, sir. Thank you.
Goodbye.
Thank you po, sir.
Bye, sir. Thank you.
Alright, goodbye.